So what have we talked about so far? We've talked about quite a few things. We've talked about distance. We've talked about position. We've talked about time. We've talked about mass. We've talked about all of these things. Mass, time, position, speed, velocity, acceleration, scalars, vectors, force, in particular net force. So we really experienced quite a bit. Net force, okay? So now what we want to talk about will be this. We want to get into Newton's laws, okay? So Newton's laws will be, this is Newton's first law. Newton's first law is also called the law of inertia, okay? It's pretty practical. It's quite a bit of common sense behind Newton's first law, once you think about it. Okay? We don't really escape these things. So it's also called the law of inertia. Okay? And we're going to describe that in just 1 second. Newton's first law states this. Wait a minute. Let me stop for a moment. Let's describe inertia. Okay? Inertia. Let's say we have ourselves a block here. Okay? Say it's wood. Okay? So this wood block, given it, let's just say it has certain dimensions. This wood block has a certain amount of mass associated with it. All right? This mass is our quantification of inertia. Just in case you don't know what inertia is, mass quantifies inertia. Here's a way we can describe it. This is a way you can think about it. What if we had a lead block? All right? If this block was lead, and let's just say that the dimensions were equal, the mass of this lead block, and let's say the mass of this wood block, the mass of the lead block would be greater than the mass of the wood block. The reason why you know that is because it's harder for you to move the lead block than it is for you to move the wood block. Now think about this. This is what's really happening. When you start talking about inertia, inertia is the resistance that you're going to experience when you attempt to change the state of this lead block or of a wood block. It's the resistance that you have. If someone were to throw you a wood block, you're more apt to catch it. You know how to control it. You know how to move with its rhythm so as to slow it down in a non-threatening way or non-volatile, non-damaging way to your body. But if someone was to throw a lead block and you knew it was lead, you'd have to act with that with a bit more caution, because it's going to take more of your body strength, more of your body, in order for you to slow that block down. Okay? It's the idea behind you running. If you're running real fast and then you see someone and you need to stop, you see an obstacle coming your way, or you're fastly approaching an obstacle that if you run into it, you're going to cause damage. So what do? You try to stop. Do you stop immediately? No. What you end up doing is it takes you a little time to stop. That resistance that you are experiencing is what we call inertia. Okay? So what is Newton's first law? Newton's first law states this. Newton's first law says that an object that is at rest tends to remain at rest, or an object that is in motion, that has some speed, some velocity. Velocity is more accurate, more unambiguous. That has a velocity, an object that is moving in a straight line tends to stay moving in that straight line unless we act upon these objects with some force, some external force. So we can apply an external force here. We're going to call that net force. If we apply an external force to an object that is at rest, what are we going to do? If we accelerate this object, what are we going to cause this object to do? It's going to move. All right? In the same way, if we apply a force to this object, and it's opposing the direction, what's going to happen? A net force. This object is going to come to a stop, or is at least going to slow down. Okay? So that's the idea behind Newton's first law. An object that is at rest tends to remain at rest, or an object that is in motion in a straight line tends to remain in motion in a straight line unless it is acted upon by some external force. Booyah!